Looking at the warm-up says write the equation in slope-intercept form. Do you remember how to put it in slope-intercept form? You have to put it into y equals. So we want it to be y equals mx plus b. This is how we want it to look. So what do I have to move over to the other side? The 4. How do I move over the 4? Add it. So you add the 4x to both sides. Because we have to remember all this, right? And we have 4x plus 3. And then what do I have to do to every single number? Divide it by 2. So you divide it by 2. And here we get y is equal to, this should be 2x. And then 3 over 2 will just remain 3 over 2. All right, so we would leave that one as 3 over 2. So it could look like that as a fraction. And we can also have it as a decimal. Just depending on what option they give you. Okay? All right, let's go on to today's. So going off of what we did yesterday, if you were out yesterday, this is what we did. So do you remember what the A represents? The A always represents the initial. Good job. The initial value. The initial value. And it also represents another thing. The y-intercept. If you're looking at a table, you're looking for the y-intercept. You're looking for a graph, you're looking for the y-intercept. In your word problems, though, talk about the initial value, okay? And what does B represent? B represents the growth and decay. Good. The growth and decay factor. So just what is it growing by? What is it reducing by? Just one or the other. All right, so with our highlighter, all we're going to do is we're going to go ahead and fill out these little charts. With the first one, you're going to highlight the number, always a number inside the parentheses. This is the one that determines if it's going to be growth or decay. 1/4, is that greater than 1 or less than 1? Less than 1. So 1/4 is less than 1, so is that growth or decay? That should be decay. The factor, again, is the 1/4. It's whatever's in that parentheses. All right, the initial value, what's our initial value? Our initial value is 8. It's just the number in front. This is your initial value. Bless you. Initial value. All right, let's go to the next one. Let's go over number 2. You're going to do the same thing. Highlight what's in the parentheses. That determines growth or decay. Is that number greater than 1 or less than 1? Greater than 1. So is this growth or decay? Growth. Our factor is 3. Good. Initial value is always in front. 2. All right. Go ahead and finish off the last 2 without me. So this one got a lot of us, right? Because there was only one number. Whatever number's there is automatically your growth or decay. That's going to still determine one or the other. So being that it's 4, is 4 greater than 1 or less than 1? 4 is greater than 1. So then this is growth, which means it is a factor of 4. Good. Yesterday we talked about this. The reason we have this formula is because this was the initial one after we plugged everything in. And then we rewrote it yesterday to look like that, which then means the initial value is what? The initial value is 1. It's not always written, right? So if there's nothing there, if there's just that one number in front of that one number, there's a 1. All right, we all should have had this one because this one had all the pieces. For some of us, we don't know if that 5/2 is greater than 1 or less than 1. So we just enter it in the calculator, control enter to make it into a decimal. So what does that give us as a decimal? 2.5. 2.5, is that greater than 1 or less than 1? Greater than 1. So this should be a growth with a decay factor, with a growth factor of 2.5. Good. And then what's the initial value? 1/4. That's your initial. So it's going to be 1/4. All right, so here we are. Yesterday we looked at a table. It says the table contains some points on the graph of an exponential function. Based on the table, which function represents the same relationship? What is your initial value? What is the initial value? 0.0625, right? It's always the one with the 0. It's this pair that you look at. Specifically, you're looking at this number. should that number be the one next to the x or the very first number you see on your equation? Very first number. And if you notice, this is the only one that has it there. Didn't even look if it's growth or decay. The moment you see that initial, if the option's there and it's the only one, you already have your answer. Okay? This one's from a graph. What did we say earlier? It's your initial value, but it's also your y-intercept. Where is this crossing the y-axis? At the 1. That means the very first number should have a 1. I can see that this one already has a 2, so I can cross that one out. That cannot be an option. Then you look at your graph. Is your graph growing or is it decaying? Decaying, it's coming down. You go left to right. This is coming down. From left to right, this is coming down. So this is a decay. Am I looking for a number greater than 1 or less than 1? Less than. This is greater. This one's greater. This is the only one that's less than 1. That has to be your answer then. Just know your piece. As long as you kind of remember your pieces, you should be fine. All right, when you're ready, we'll go over to the back side. All right, so on the back side, we have more graphs, right? We're just going to look at them and decide what our pieces should be here. Always read your graph left to right. So here's the left side. You're reading it. Is it going up? Is it growth or decay? Growth. So you're going to circle growth. We said your initial value is always where it crosses the y-axis. So this little point here, that is your initial. 2. Your initial value is 2. Horizontal asymptote, we talked about that yesterday. What's the line that it never crosses? This never changes. It's the x-axis, but what's the equation for that asymptote? It's okay if you forgot. It's y equals 0 because it crosses the y-axis at the 0. Y equals 0, okay? Horizontal asymptote, y equals 0. The domain, we hadn't talked about that. What do you think your domain is? Do you think it's only going to hit a certain set of numbers, or is it going to hit all the numbers on that x-axis? It's actually all the numbers, yes. This is going to continue over to the left side, but it's just going to get smaller and smaller as it keeps going. This is going to continue and slowly, gradually go up, depending what the growth factor is. So this is going to be all real numbers. So again, you can do your symbol, or you can write all real numbers. Whichever one you want to do, just know both, okay? Your range. All right, so your range from that horizontal asymptote always has to be greater than 0. It's going to always be greater than 0. We'll never touch 0, just always be greater than. All right, so we have the initial value. We haven't even looked at the growth factor. Going from the initial value, but knowing that it's growing, which equation should be the correct equation? B. Why B? Because 3 is greater than 1. All right, so 3 is greater than 1, which is growth. All right, let's do another one, and then you guys will try the third one, okay? Look at this one here. You read, again, look at your graph going left to right, left to right, left to right. Is this growth or decay? Decay. Okay, where's your y-intercept at? 3. All right, so that's 3. Horizontal asymptote that never changes. What do we say that was? Y equals 0. Your domain is going to always be all real numbers. Your range should always be what? Y is greater than 0. Okay, it's never going to cross it. All right, so because this is decay with the y-intercept of 3, which one is our equation? YA. 1 over 3 is less than 1. All right, that's supposed to be a 3, sorry. All right, go ahead and try that last one without me, okay? All right, I know we didn't use a highlighter on the other two. If you want to, something you can highlight could be this point, just so you know what we were looking at. All right, so looking at number 9, did y'all pick growth or decay? Growth, good job. Our growth value, or the initial value, is going to be what? 0.5 or a half, right? And we're kind of estimating that because we don't know the exact. So this is your initial. It's also your y-intercept. So either a half or 0.5, right? Either decimal or fraction form. Horizontal asymptote, y equals 0. What about domain? All real numbers, good. What about your range? Y is greater than 0, good. So if this is a growth with an initial value of a half, which one's your answer? A. They use the same numbers, or they use the exact same numbers on both of them. You're looking for that initial value. That should always be first. The initial value is always listed first. Okay? All right, so the last thing we're going to get to, is the word problems. It says, suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function of f of x equals 30 times 2 to the x power gives the population after x weeks. How many beetles will there be after 4 weeks? So all you're going to do here, now x represents the number of weeks. And they tell us exactly how many weeks, right? They said 4 weeks. All you're going to do here on your calculator, you don't even need to graph it. You're going to take this, and where the x is, you're going to plug in the 4. So you're going to do 32, and you're going to raise it to the 4th power. So let me give you a minute to go ahead and get that entered in your calculator. So what did y'all get? How many beetles after 4 weeks? 480. I got 480. Did y'all get 480? 480? Okay, should be 480. 480 beetles. Okay, that's all it is, right? They're word problems. Just don't be afraid of the word problems. Okay, it says, in January 2021, the population of the city of Brownsville has grown according to the mathematical model of 720,500 times 1.02 to the x power, where x is the number of years. So x represents the number of years in this case, so x is the number of years. This equation was derived in 2021. Explain what the number of 720,500 represents, as well as 1.02. What does that first number represent? What is that number? In regards of growth, decay, or initial, which one's that one? Your initial. So this number represents the population in 2021. It's your initial population. Your initial population. I spelled initial with 2 INs. There you go. Your initial population in 2021. What does the 1.02 represent? Remember, what does that second number represent? Growth or decay, right? And in this case, is it growth or is it decay? It's your growth factor. Okay, don't forget, right? I know it's a word problem, but they represent the same thing. So the next piece says, what would the population be in 2030 if the growth continues at the same rate? So this one is not identical to the one on top, because this one has 2030. We're not going to put 2030 in for x. We can't even put 30 in for that x value, because what you have to take into consideration is that this equation was derived in 2021. We're now in 2030. How many years have passed? 9, right? 9 years have passed. So what you're going to look for is you are going to look at the equation, but for the x, you're going to substitute in the 9. So you're going to enter 720,500 and then times 1.02, and then this is going to be to the 9th power. All right, so let me just move that over in case you didn't copy that first piece down. What did y'all get for the population here? Does it start with an 8? Okay, so what? Just tell me the numbers. 8, 6, 1, 0, 6, 4. So 861,064 would be the population. Right, and it should get bigger because it was growing, right? It was growing, the number should be bigger. All right, it says use the model to predict about when the population of Brownsville will first reach 1 million. All right, so we'll do that here in a bit because I need to get back to the calculator in the back. Let's go to the next one real quick. It says a population of 10,764 beetles is decaying each month at a rate of 40%. Write an equation that represents the number of beetles at time x. Okay, so what is my initial value?
10,760.
All right, so that's your initial. All right, my rate is 40%. Now, we're not going to put in 40, though. Do you remember how to convert 40 into a decimal? Okay, so all you do is you take your 40. We're going to do this tomorrow anyway. You put your decimal at the end. Anytime you're converting it, you're going 2 to the left. So you're just going to go 1, 2, and move your decimal there. So that would be 0.40. That's the number we have to use for growth or decay. What is this going to be? What did it say it was going to be? Decay. Okay, so then the equation, what would I write for the equation? I would put y equals, what number goes first? 10,764, and then parentheses, what goes in the parentheses? 0.40, and then to the x power. The x power being whatever time frame we're looking at, whether it's weeks, days, months. Now, this one is in months. It says about how many beetles would there be in 8 months. So how do we enter this in the calculator? What am I changing? The x to a 8. All right, so let me give you a minute to go and enter that. I'm going to move over to the back. That way I can get that calculator up for that one we went over. Okay, so mind you, that 40%, is the decay at every month, and we're doing this for 8 months. What did y'all get for your answer? 7.0543. Right, so there would be about how many beetles left? About 7 beetles, right? Because you're gonna round it to the nearest whole number. You have it graphed in the calculator. You're going to press Control-T for the table, and then you're just going to scroll until you hit the millions. So it hit the millionth right here. How many years have passed? 17. So that would be 17 years. So on your notes, I want you to... What now?
Mine just shows like all the same numbers.
Let's see. So let's write that you're going to graph. Let's see. We would graph 720... 500, 1.02x, and then you just look at your table. And we said this would be how many years? What did we say? 17 years. 17 years would be our answer.